You wake up hungry. You open the fridge. You grab something, heat it up, and eat it without a single thought. That is not how it worked for most of human history. For millions of years before anyone struck a spark on purpose, your ancestors ate everything raw. No stove, no fire, no shortcuts, just teeth, stomach acid, and whatever the land gave up that day. So, what did they actually eat? The answer is stranger, riskier, and more resourceful than you have ever imagined. Start with the timeline, because it changes everything. Modern humans have existed for around 300,000 years. The wider human family tree stretches back nearly 3 million years. But controlled, everyday fire use? That only became routine somewhere between 400,000 and a million years ago. Do the math. That leaves millions of years of pure, raw survival before cooking ever entered the picture. Meat came first, and it came raw. Scientists have found cut marks on animal bones dating back at least 2.5 million years, made by simple stone tools. That is proof your ancestors were butchering and eating meat over a million years before they could cook a single bite of it. Picture what that actually meant. Raw muscle is tough. It fights back against your jaw. That is why early hominin skulls carried massive jaw muscles and oversized molars, built for grinding through fiber and cartilage that modern cooked meat simply does not have anymore. Your jaw today is smaller. Softer food made it that way. And the danger did not stop at texture. Raw meat carries bacteria, salmonella, E. coli, parasites you do not want to think about. Every raw meal was a gamble. So how did anyone survive that gamble long enough to pass on their genes? Part of the answer sits in your gut right now. Researchers believe early hominin stomachs carried unusually strong acid, strong enough to kill off a meaningful share of dangerous bacteria before it could do damage. But strong acid was not a guarantee. It was a buffer. People still got sick. People still died from what they ate. Illness from food was simply one more risk layered on top of an already brutal world. Some parts of the animal were safer and smarter. Choices. Organ meat, like liver and brain, is soft. It needs far less chewing than muscle. And bone marrow, that was treasure. Archaeologists keep finding ancient bones smashed open in very specific patterns. Patterns that only make sense if someone was cracking them open on purpose to reach the fatty marrow inside. Pure, concentrated calories with almost no effort required to eat it. Here is the twist most people never consider. A lot of that meat was not even freshly killed. Early humans were scavengers as much as hunters, pulling meat off carcasses that other predators had already killed. That meat ranged from fresh to fairly far gone. Modern scavengers like hyenas and vultures eat decomposing meat constantly with no issue. Your ancestors likely did the same. Out of necessity, not preference. Now shift to plants, because plants were doing the heavy lifting calorically. Here is where it gets genuinely fascinating. Starchy foods, tubers and roots especially, are locked in a crystal structure your digestive enzymes cannot easily break into when raw. Cooking unlocks that structure completely. Raw, a meaningful percentage of that starch just passes straight through the body. Undigested, wasted. So how did anyone get enough calories from tubers before cooking made it easy? Researcher Richard Wrangham has spent years exploring exactly this question. The likely answer is that early humans leaned less on those hard-to-digest starches and more on foods that did not have this problem at all. Ripe fruit, already packed with easily absorbed sugar, nuts and seeds, dense in fat and protein your body can use immediately, raw or not. Insects deserve real credit here too, and they rarely get it. Termites, ants, grubs, beetle larvae, reliable, available year-round, packed with fat and protein. Chimpanzees, your closest living relatives, still use tools today to fish termites out of their mounds. That behavior almost certainly echoes something your ancestors were doing millions of years ago, long before any of them cooked a meal. Now here is where the story turns from what did they eat into what did eating raw actually build inside the human body. This next part might change how you see your own anatomy. Your gut, right now, is smaller relative to your body size than a chimpanzee's gut. That is not random. Scientists Leslie Aiello and Peter Wheeler proposed something called the expensive tissue hypothesis. The idea is simple but powerful. Digesting raw food requires a large, energy-hungry gut. Cooking eventually softened that burden, letting the human gut shrink. And once the gut needed less energy, that spare energy had somewhere else to go, straight to the brain. Which means before cooking, hominins carrying the older, larger, more expensive gut were working under a strict energy ceiling. Bigger brains simply were not affordable yet. Every raw, undercooked calorie extracted less energy than it could have. That energy limit may have quietly capped how large the human brain was even allowed to become. There is more written into your own teeth. Scientists study microscopic scratches on ancient tooth enamel, and those scratches tell a consistent story of heavy mechanical stress, exactly what raw, tough, fibrous food would cause. Not every ancient species chewed the same way, either. Some hominin lineages, like Paranthropus, developed massive jaws built purely for grinding through extremely tough plants. Your own lineage went a different direction. Less brute anatomical power, more flexibility, more strategy. And that flexibility might be the real answer to the whole question. Early humans were not the strongest species on the savannah, not the fastest, not the best armed. What they had was adaptability, the ability to scavenge when hunting failed, to eat insects when meat was scarce, to choose fruit over tubers when raw starch was not worth the effort, to move with the seasons instead of starving through them. Even water was a battlefield back then. No fire meant no boiling, and no boiling meant no way to kill off waterborne parasites and bacteria before drinking. Every sip from a stream carried its own quiet risk, stacked right on top of every risky bite of food. Food could not be preserved either. No smoking, no drying. A large kill had to be eaten fast before it rotted in the heat. That single, simple pressure likely shaped something deeply human, the instinct to share a big kill widely and immediately rather than hoard it and watch it spoil. That instinct to share resources under pressure, it may be older than fire itself. So the next time you open your fridge without a second thought, remember what that convenience actually replaced. Millions of years of calculated risk. Millions of years of chewing through tough, raw meat and gambling on unclean water. Millions of years of choosing fruit over starch, insects over hunger, and sharing meat before it spoiled. Fire did not create human cleverness. It simply rewarded cleverness that had already been quietly building, one raw and uncertain meal at a time. You wake up hungry. You open the fridge. And now you know exactly what your ancestors would have given anything for.